Hello students, in this video we are going to see about electric drive system. The basic elements of an electric drive system are electric power source, power processing unit, that is Powertronic converters, motor, sensing unit and controller. This is the block diagram of general electric drive system. If you see this, that electric power source is connected to the input of Powertronic converter, and then the output of Powertronic converter is connected to motor, and then motor is coupled with mechanical load, and various parameters from motor and electrical load is sent to some sensors, and that parameter is fed to controller. From controller again that information is given to power electronic converters. So normally in Powertronic converters gating pulses will be varied. This controller receive signals from motor as well as from load, and it is processed in the controller, and then it is fed to power electronic converter for adjusting the power flow. These are the various sources, not limited to this. If you see AC source, 230 volt single phase, 440 volt 3 phase, that also categorized into star delta, 3.3 kilovolt and 11 kilovolt 3 phase AC system. Variety of types of AC sources are available. In case of DC source also, variety of sources are available, 12 volt, 10 ampere, 110 volt, 100 ampere, 1000 volt, 1000 ampere or 100 ampere, like that variety of sources are available, not limited to this. Different type of Powertronic units are there: converters, DC choppers, inverters, AC voltage regulator. Converter which converts fixed AC into variable DC, whereas DC chopper converts fixed DC into variable DC. Inverter, it converts fixed DC into variable frequency AC as well as variable voltage in the case of PWM inverter. Whereas the AC voltage regulator, it converts fixed AC voltage into variable AC voltage. If you see AC motors, different types of AC motors are there: induction motor and synchronous motor. Under induction motor, it is again classified into single phase induction motor and three phase induction motor. If you see the types of three phase induction motor, it is squirrel cage and slip ring induction motor. Single phase, it is classified into capacitor run, capacitor start run, shaded pole and split phase induction motors. This is the circuit of various types of single phase induction motors. First one is capacitor run motor. You see here two windings are there, one is main winding and another one is auxiliary winding. For this auxiliary winding, a capacitor is connected in series. So the voltage across this auxiliary winding is 90° phase shifted when compared to the main winding voltage. Whereas in the case of capacitor type motors, the phase shift is created due to the capacitors. Here it is due to shading coil. The last type is split phase induction motor. As like other motors, here also you will find both main winding and auxiliary winding and centrifugal switches there. If you see the types of three phase induction motor, two types are there. One is squirrel cage induction motor and second one is slip ring induction motor. If you see the construction of squirrel cage induction motor, stator is made up of three phase winding and rotor is a short circuited bar. If you apply a voltage in the stator, in the air gap rotating magnetic field will be formed. Due to that rotating magnetic field, EMF is induced in the short circuited rotor. Due to its short circuit nature, a current flow happen in the rotor that magnetize the rotor, then it works as a motor. This is how squirrel cage induction motor work. Whereas in the case of slip ring induction motor, three phase windings are available in both stator and rotor. That rotor winding is connected to a carbon brush with the help of slip ring. Through carbon brushes, we can able to connect rheostat. By varying the rheostat, we can able to vary the starting torque of slip ring induction motor. Through this slip ring induction motor, we can able to recover slip power also. So that is the biggest advantage in slip ring induction motor. The biggest drawback in slip ring induction motor is the presence of slip ring and carbon brush in the rotor. So it will create a spark. Maintenance of slip ring induction motor is also difficult as like DC motor. That's why its application is limited to certain areas, whereas scroll gauge induction motor is used in a variety of application in industries. So this is the diagram of synchronous motor. Stator is made up of 3-phase winding and rotor is made up of DC winding. If you provide a DC supply to this rotor, it will get magnetized. Thereby interlocking is possible in this motor. This synchronous motor always runs at synchronous speed, whereas this induction motor, it never runs at synchronous speed. So for constant speed application, synchronous motors are preferred in industries. So if you compare as a whole, if you take a squirrel cage induction motor, it is widely used. The torque is moderate. Take a slip ring induction motor, it is used in specific application, not in all places. But starting torque is higher compared to squirrel cage induction motor. Whereas this synchronous motor, for constant speed operation, industries are using this type of motor. In many places, this synchronous motor is used as synchronous condenser. It can operate in all the power factor modes, that is lagging, unity as well as leading. So this motor can be used as synchronous condenser for compensating the reactive power in industries. This is the circuit of DC motor. So first type is separately excited DC motor. Here if you see that armature and field is separately excited. For both armature coil and field coil, supply is different. So that's why it is named as separately excited. Whereas if you see the shunt, that armature and field winding is parallelly connected and it is fed through a single source. That's why it is called a shunt motor. Whereas in the case of series motor, that armature winding is series with the field winding and it is fed to a single source. For cumulative compound motor, both series as well as shunt winding is there. You see sensors, different sensors are used in electric drive system. The main sensors are voltage sensor, current sensor, speed sensor and temperature sensor. Apart from that, many sensors are used in drive systems. These are the various advantages of electrical drives. The main advantage is flexible in control and accuracy in speed. And apart from that, another main advantage is energy saving. The power consumption in electrical drive is very low when compared to the conventional drive system. So other than that, many advantages are there. These are the applications of electrical drive system. You see all the places, paper mills, electric propulsion, plant automation, robotics, mining equipment, power tools, electric traction, aerospace actuators, cement kilns. So in all the places drives are used. In all the industries, definitely a drive will be there. These are the different types of electrical drives. One is group drive, second one is individual drive, third one is multi-motor drive. If you see the diagram of group drive, a single motor is used to operate many loads. You see a rice mill, single motor will be there, and it is used to drive many loads. That type is called group drive. Second one is individual drive. Here each load is connected with a separate motor, like mixie, grinder in our houses. Okay, that is called individual drive. The third one is multi-motor drives. So here many motors are used to drive a single load. If you see crane, many motors are used to drive a single load. So that comes under multi-motor drive.